Okay, so let's get started today real quick before I get too far ahead here. Okay. So again, this idea that in math things start getting more difficult as the math gets more difficult, and as a result, there's two things that often really confuse students. One is the vocabulary, which is just a fancy term for words, okay? All of a sudden, math teachers start throwing out words, and you're like, what does that mean? What does that mean? What does that mean? You start reading it on a test. Well, what the heck is that? What is an exponent? That doesn't make sense to me. What is a equivalent fraction? I don't understand what that means. So be careful. Sometimes, again, these words, please don't try to make them confusing. Try to sometimes simplify them to just what they actually are. Is the fact that the vocabulary gets confusing. The second is, to be honest, that math has a lazy factor to it. Now, you may not think that right away. It doesn't seem like math is a lazy subject. But in a lot of ways it is, in terms of the way it's written. And lazy isn't maybe the right way to put it. But the fact is, math teachers, math people doing math don't always want to write 2 times 4 times 2 times 4 plus, like, it's too long. It's too much work. So they end up shortening things, right? They end up saying, well, I don't want to draw an X. I want to draw a dot. I don't want to draw a dot. I want to just use brackets. I want to do this. So they start shorthanding things. They say to themselves, well, really, isn't that just 2 squared times 4 squared? Well, it is. It's the same statement. They mean the same thing, but you kind of have to understand that this laziness is being put into words in a way that makes it hard, okay, for some students. So the first thing is kind of learn the language. Learn the language of mathematics. The second thing that I can't recommend strongly enough is come up with and I'm going to use a few different words to describe it, a system, or a method, or let me take it out of these sciencey words, a recipe, or an instruction. Okay, here's what I mean. If I handed you a brand new iPod right now, okay, or a brand new iPhone, and you'd never encountered this device before, you'd probably be wanting to kind of figure out how it works. And one of the first things, and maybe iPhone isn't the best example. Let's say it was something like a lawnmower, okay? And you weren't really sure how to turn it on, how to make it run, et cetera. Simon?
Isn't there that?
Well, we'll get to that. Thank you for. I'll use that as an example. But with the lawnmower, you look for example, a set of instructions. So here in the box is a set of instructions that tells me how to use it. Okay? Let's say you want a cake. You're dying for cake, right? You have no idea how to make a cake? The recipe gives you, same thing, a set of instructions on how to make a cake. These other two words are a little more sciencey, but they essentially mean the same thing. All those words essentially is it's a way to get from A to B, where A is the problem and B is the solution. And honestly, what a lot of you want is this. You have a math test in front of you. You want the answer so that you get it right. You've been given the problem. What's in the middle, what's right here, is these. A system, a method, a way of getting from A to B, a way of getting to the answer. Okay? And in math, I try to do that. And Simon brought up a good way that sometimes is a way to is a system like BEDMAS. It's a little memory technique that gives you a technique to get from A to B. Today I present a similar technique. It uses a little bit fancier vocabulary, but it is essentially just a way to get from A to B. And in math, we call it a law. Okay, don't overthink that word. It's not like, like the law that's going to walk in here and arrest you or anything like that. It's just, as I said before, simply a technique. That's another word we could possibly use, is a technique. You could use that word in the context of, say, a sport, right? You don't know how to do a certain stroke in swimming. Like, oh, I don't know how to do the reverse dolphin kick or something. I don't know. My daughters and all that stuff. But someone will show you, here is the technique. Here is the instruction. Here is the recipe. Here is the step-by-step way to get from problem to solution. Okay? Today, it gets complicated. When I say it's the power laws, okay, you start thinking about your vocabulary. Well, you've learned what a power is. You know that laws are just some techniques. Hopefully then it's not too intimidating to you. But I'm warning you, and I already have, that in some ways, some will find this kind of tricky. Okay? All right. Let's get started. Okay. As always, I'll show you what the teacher write-up looks like. We'll skip over most of this, but what it says in the actual curriculum on this matter is as follows. Turn it on. There we go. Okay. A lot of things are written here, but shh. What's important is, specifically this point, explain using examples the exponent law of powers. So that was the words I was just mentioning. Notice again, they're adding a lot of extra words like integral bases, whole number exponents. Let's not overthink all that. Today we focus on that. The power laws. Okay? And let's take a look at what I mean by that. All right. So let's start with what math really is. It's the search and study of pattern recognition, okay? So you guys have kind of done some power stuff. So let's start with some simple ones. And again, you can maybe do this in your head. Maybe you could use a calculator. But can anyone tell me what's 3 to the power of 4? What's the answer?
81.
Anyone disagree? No? Everyone agrees? And if you were to write that out, what would you write it out as? In the standard way. That's right. You got it. Hopefully, all of you got it. Hopefully, all of you who are staring at me right now got it. If you aren't staring at me, and if you're not listening, chances are you're not going to get it, which will relate to the way it's going to work on your tests. But you're right. It's 81. So what's 3 to the power of 3? It's even easier.
27.
Very good. Now it gets easier. Now, this one I've never shown to you before. But how would you, before you get the answer, how would you write that out? Because if you wrote out this one, 3 squared, you'd write 3 times 3. But what would the next one look like?
3 times 0.
So what would that be?
3.
No, 3 times 0 is not 3.
Oh, 0. 0.
3 times 1?
No, just 3.
Just 3?
Yeah, that's 3 times 1.
It's just 3. Okay, shh. You're right. It is just 3. Okay? But now, let's go a little bit weirder. Now we got to get a little outside the box. This one maybe, you can't think of it in the way you were thinking of the other ones. But if you think of this in terms of a pattern, knowing what's happening to this side, what do you think is going to go there? 0 would be an excellent guess. Excellent. It's wrong, but it's an excellent guess. And I would have, if I was in your spot right now, I would have guessed the same thing. That's also a good guess, also wrong. Shh. Okay, guys, settle. Okay? Fiona. Which one? Nothing there, so there's no answer. Also good guess, also not correct. You think it's 0? It's not 0. It's not 3 either. No, 0 stands for 0. It's tricky though, but okay, couple more guesses. What do you think? 1 is correct. Now, I'm going to mention this first here and then later in the presentation again. Anything, any number, any single number to the power of 0 gives you 1. anything. This binder to the power of 0 equals 1. This young lady to the power of 0 equals 1. My shoe to the power, no, I'm just kidding you guys, but literally any number to the power of 0 equals 1. It doesn't make sense at this point. Hopefully by the end it makes a little more sense, but it's one of those things at this point that I'm going to just ask you to accept, and I'm going to try to prove to you a little bit later. Yes? You can try. Yeah. No. Good. Excellent guess. But actually the next one, I'm not going to tell you today. As a matter of fact, exponents of a negative value are actually not part of your grade 9 math curriculum. So I only put it there to tell you, you know what? You don't have to worry about it. But I am going to tell you, not today. It's like a cliffhanger. I'm giving it to you guys as a cliffhanger. Okay. All right. Okay, let's slow down. Shh. No, it's not a negative number. It's actually not even a negative number. No. Okay. Let's pull back from that now. Let's take a look at this. 2 to the power of 5 times 2 to the power of 3. If we didn't know about powers, we could write this like this, right? Which is 2 to the power of 5 times 2 to the power of 3. We could do that. But we don't even need those extra brackets in there. Really, we could just write it like that, right? But now, wait a minute. If I can write it like this, does anyone know another way I could write it that's lazier? Rain? 2 to the power of 8. And now I ask you a question. Do you notice a relationship between the 5, the 3, and the 8? A pattern almost. Let's try another one. Let's do a division question. Y to the power of 7. Now here I'm just going to use a variable. Divided by y to the power of 2. Let's write it out as if we didn't know what powers were. It would look something like this. That's what y to the power of 7 would look like. This is y to the power of 2. Now, you know when we do division, we can kind of cross things out. So let's do that. Let's cross out that y with that y. Let's cross out those two y's. Now we could rewrite this. It's just really just that. And what's that if I was lazy? What would it be? Y to the power of 5. Next question. Do you see a relationship between the 7, the 2, and the 5? We're starting to see the pattern. What you're seeing here are the beginnings of what people, when they started playing around with this type of math, realized is, I can be even lazier. I don't have to do all this to figure out the answer here. I could come up with a quicker way to solve this problem, a method, a way to get from A to B. And I'm going to call that the power laws. So let's take a look at these exponent or power laws. Starting with law number 1. It's called the product law. When you multiply any two numbers that have the same base together, all you need to do to the powers is add them. Let me give you an example. Okay? Well, I'll give you an example in a minute. And then the second one, which you guys just saw, the quotient law, is when you divide two numbers with the same base, you subtract the exponents. Now, you can solve these problems without the laws, but the laws are a shortcut. Okay? The laws are a shortcut to get the answer. We're going to do some examples. You're going to do some questions in the assignment. But this is the basic laws, the first two laws. Okay? Do you want an example right now? Maybe I should just quickly just throw up an example. Okay? I'll just do it up on the smartboard. Okay. So for example, 5 to the power of 3 times 5 to the power of 4. In order to apply the laws, the base has to be the same. So in other words, if I was to do this, 5 to the power of 3 times 4 to the power of 4, can't do that. Why? Because the bases are different. Remember, in a power, this is the base, and this is the exponent. We learned that in part 1. Okay? So this one, I can't apply the power laws. It doesn't apply. But this one does apply. I can apply that power law. The power law said anything with a exponent times the same base with a different exponent equals that same base where I add the two things together. That's what the law said. So here I can apply that and I can go, well, the answer is going to have the same base, and all I have to do is add those two things together. And I'm done. So much faster than me punching that in my calculator times punching that in my calculator, coming up with some big answer. Now I could just punch one thing in my calculator. It's a shortcut. It's a way to get from A to B. That is a technique that you can learn, and it's called the first power law. Let's try another one. Okay? Now what if I said 5? Actually, let's go with a bigger number. Actually, let's go with a variable. Let's say you don't know. Let's say it's A to the power of 10 divided by A to the power of 7. And I could have written it this way as well. I could have said A to the power of 10 divided by A to the power of 7. Okay? Both mean the same thing. So now I got to go do this. Now if I wanted to, I'm kind of trapped. I don't even know what A is at this point, so I can't really calculate this on my calculator. But one thing I do know is I have that exponent law. Anything with a base divided by that same base with some other value equals that same base with the one minus the other one. Ah, now I got a technique. So I know the answer is going to be A, same base, and I take that, subtract that, and I'm done. Okay? So the power law gives you a bit of a shortcut to get the answer with a little bit less work. But you got to know the law. You got to know the technique. You got to know the recipe. Okay? Here's a couple more. You're going to have a total of 6 laws today. These are the first 2. Law number 3. This is the weird one that I tried to show you guys at the beginning. Anything with an exponent of 0 equals 1. Anything with an exponent of 0 equals 1. What I'm going to try to do now is show you why. It's a bit of what's called a proof in mathematics. Okay? So what I'm doing here is I'm basically saying x to the power of 3 times x to the power of 0. Okay? Yes?
I guarantee you I can answer any question you put on the board.
Okay. Okay, we'll get to that. Have patience. Okay. So here I can, don't look at the whole screen, just look right here. X to the power of 3 times x to the power of 0. If I use the law I just talked about, I can add them. Right? But what's 3 plus 0? 3. So notice it didn't change. It's like as if I times it by some value that would not change the value. What's any number if I had like 27, what number could I multiply 27 by to get 27? 1, right. So it kind of says anything to the power of 0 is equivalent to 1. Now, luckily, you guys don't need to completely grasp that proof or anything like that. Again, depending on the maths you guys take in your future, proofs can be more and more part of math. But right now, trying to prove it to you. Okay, so I could give you an example of this, but it's so easy. Anything to the power of 1 is 1. You're done. Law number 4. This is called the power to a power law. What it says is, if you have some value raised to a power, and then raise that thing to a power, so here I have x to the power of m, and then that whole thing is raised to the power of n, all I got to do is multiply those two things together. Allow me to give you an example. Here we have x to the power of 3, and then that whole thing is raised to the power of 2. Now I could do the math on that, okay? But what I can do is take a shortcut here. Knowing that law, I can just multiply those two numbers together. I can just go, oh, well, what's 3 times 2? Oh, well, it's just x to the power of 6, and I'm done, okay? And again, I can apply that to an actual value. If I wanted to, I could just say, okay, what's 4 squared to the power of 8? Now again, you could be punching that all into your calculator, or you could just realize, oh, all I got to do is multiply those two. It's really 4 to the power of 16. and you're done, right? So it's a technique to help you, whoops, with those power laws. Where is it? It's running in the background there. Come on, where are you? There we go. Okay. Law 5, power within a product law. Getting a little trickier. So here, inside the brackets, I have two values being multiplied together. In this case, it's x and y. Those two values being multiplied together are both being raised to the power of m. Well, what I'm saying here with this is, you could also rewrite this as x to the power of m, y to the power of m. Okay? This is also known as a kind of a distributive law. Okay? Again, let me show you an example. 4 times 3 being raised to the power of 3 is the same as 4 to the power of 3 times 3 to the power of 3. So it's like that little power is applying to both things inside. Not as widely used of a law, but it does apply in certain problems. And then from there you could calculate that if you wanted to. All right, law number 6, the final law for today. The power within a quotient law. Again, a little bit more difficult to understand. But in this case, I have two values being divided, or you could think of them as in a fraction. And that whole thing is being raised to a power. Is the same as raising both the numerator and the denominator to that same power. But there's one catch: y cannot be equal to 0. Let me show you an example. Here we have 3 over 4 being raised to the power of 3. Now normally if I gave you that question, what a lot of you might do, rightfully so, would be write 3 times 4 times 3 times 4 times 3 times 4, and that would work. Or you could convert this to a decimal and then raise that to the power of 3. You could. But you could also use that power law just now and say it's 3 to the power of 3 divided by 4 to the power of 3. You could figure out what that one is, figure out what that one is, and be done. So in a lot of cases, these 6 laws help you to get quicker to an answer. So let's try it. Here's a tougher problem. Okay, so Simon, you're up. What's that?
No, I got this.
Can't write on the board. You got to just do it in your brain. You got like 20 seconds.
Okay, just imagine an equal sign here.
Yeah.
And that there.
Thank you.
It works, right?
It does. It's not the answer. Good luck on a test with that one, but it would give you something. Okay, so here's the way I'm going to look at this. There's a couple laws I could apply here in this problem. So for example, I could take that 3 and apply it to everything inside. So in other words, 3 times 2, 3 times 3, and z times 3. So I could just switch it to that now, which would give me that. So this and this is the same thing. Okay? It's equivalent. Now this is a very algebra-like question. Let's pull away from the algebra a bit. Let's try ones that are a little bit less algebraic in nature. But before we do, here's the summary. This whole day in one shot. This is in your notes that you're going to get from me. The product law, the quotient law, the zero exponent law, the power to a power law, the power within a product law, and the power within a quotient law. Okay? These are the 6 laws that your grade 9 curriculum requires you to apply to problems in mathematics. There's actually one more that isn't part of your grade 9 math, but I'm going to teach you anyways, just not today. But one other thing about these laws is they work in reverse. And here you see an example of that. I can actually go backwards the other way. Like for example in this one, I can go back to this, whereas in the example I showed you, you can go from here to here. You can go the other way too. You can go backwards and forwards. If that's confusing to you, don't think of it that way. Don't think you can go backwards and forwards. Just think of it as a simple recipe. That's for example like you could take a cake and maybe you could break it down into its individual ingredients, but most people don't do that. They just eat the cake, right? All right. The other law is the idea of negative exponents. I will show you that, just not today. It's not what you thought it was. It's not a negative number. What it actually generates is a fractional number. Okay? Okay, so let's throw up a couple simple examples to end up. Okay, so let's try and do some of these. Okay? Maybe grab a piece of paper. Let's see what you guys get. Or if you can do them in your head, great. Let's take a look at the first one. 5 to the power of 3 times 5 to the power of 4. I don't ask you to calculate a final answer, but what would an answer be, Shanice? 5 to the power of 7, that's right. The law applies. Because these have the same base, I can just add those two. Next question, who's got an answer for this one? Now in this one it's a little bit trickier. I'm asking you, what is x? X is here. Rain, do you think you have an answer?
5 to the power of 4.
You're right. How did you get that? For those who didn't understand how she got that, please explain.
I subtract by 3 from 7.
Yes, well basically she's saying she knew the law that 3 plus something equals 7. The something is 4. 3 plus 4 equals 7. Who has a way to solve question 3? Tynan, how do you think you do that one?
5 plus 3 equals 8, so the answer...
Whoa, this one. Sorry, this one.
No, 5 minus, so that's
2, right. Yeah, watch that. Mistaking the laws. I'm glad you brought it up. Be careful. You're doing a division here, so you subtract them. So the answer is 2. Okay? Now, so this is a division as well. 6 divided by something equals this. So we know the law is 6 minus this equals 2. 6 minus what equals 2? Not 3. 4, yeah. So the answer would be the x is 4. 3 to the power of 4. Okay? Now, can anyone simplify this one? Somebody else, somebody. What's the law? Simon, help me out. Yeah, it's 2 to the power of 3 being raised to the power of 4. What do I do with the exponents? Can someone help them out? Tina, what do you, don't tell me the answer, but what do you do with the exponents?
you multiply.
You multiply them. So now what's the answer? You multiply the 3 and the 4. Right, so it's 2 to the power of 12. That's right, very good. Okay, so now that you guys know that, and you've tried it, 3 times what gives you 6? 2, right. The last one's a bit tricky, so I've actually made an animation for the last one. So here you can see a much more complex problem that involves variables, exponents, and numbers and negatives. Let's take a look at what it looks like. Okay. Oh, well, there's the answers. You guys got those. Okay. Here, let's take a look at that last question. There it is. Okay. We got lots of stuff happening here. Lots of stuff all being multiplied together. Let's start with the simple things. I've got a whole number 2 and a whole number negative 3. I can multiply those. 2 times negative 3, negative 6. I'll just keep that in mind. Then I've got an x here, and I've got an x to the power of 3. How am I going to combine those together? What's x times x to the power of 3? Well, let's take a look. It'd be x 3 plus, now if you don't see an exponent, if there's no exponent, what is the exponent? 1, right. So it's 3 plus 1, 4. Now in the last one, it's just y to the power of 3. It just is. So now I can combine those 3 things together to get the final answer here. Okay? This is a harder question, no doubt. But I wanted to put that in there at the end to show you it can quickly get more complicated. But those laws, in the way they actually are fairly simple. Okay? So this is your summary. You've already seen it. So I'm just going to put it up quickly. It's just those 6 laws. That's all I have to say about today. Today is about these 6 laws. This is what the curriculum says. Again, focus on that it's these laws. And we're ready to roll. All right. So